Good morning, students. So, in the last class, I had discussed the basic print upon which the econometric models are based. So, the basic thing is the two variable stochastic model, which I had analyzed in the last class. Taking the two variables to be income and consumption. Income being taken as y and consumption being taken by x, we had developed, initially we had developed the regression model, which was written as y is equal to, x is equal to a plus by. X is equal to a plus by. Consumption is equal to a plus b of income. How income influences consumption. After developing the statistical model, the statistical equation, we then proceeded to analyze the basic thing upon which the entire set of econometric discussion is based. That is the stochastic case. The inclusion why the disturbance term is included in the model that I had discussed yesterday. So the stochastic model is written as x. You can write x is equal to a plus by. X is equal to a plus by plus u. This is the stochastic model where x is consumption, y is income, and most importantly, U is the disturbance term. U is the disturbance. So why we include the disturbance term? Why we incorporate the disturbance term in the model? I had analyzed the details yesterday in the last class. Now the problem is that how to represent the relationship between income and consumption in a proper way so that we can forecast about the various probable values of consumption given various possible values of income. So to get that line is the line which most appropriately represents the relationship between x and y or income and consumption is known as the line of best fit. It is known as the line of best fit. So it will be a linear straight line. But how to derive that linear straight line? That is the point. So we have to derive the values of the coefficients a and b from the data. I had given the example of a numerical example yesterday, which can be represented as 780 plus let us suppose 0.8y. Let us suppose this is the numerical form of the relationship between income and consumption. As I have explained, this is autonomous consumption, this is marginal propensity to consume, which shows the average relationship between consumption and income. Now, the point is how to derive these coefficients. How to derive the coefficients of intercept and the slope. How to derive the coefficients of autonomous consumption and marginal propensity to consume. To do this, to derive this, we use the most popular method. There are three different methods are there. 3-4 different methods are there. The simplest and the widely used method is referred to as the OLS method. It is referred to as the OLS method. That is abbreviation optimum least optimum least square method. So how to apply this method? And applying this method, we shall derive the particular line, which will be known as the line of best fit. Now, our problem is how to choose that particular line. How to choose the line of best fit. So we have some data. We shall have some data on income, various income levels and corresponding consumption levels. On the basis of that data, we shall fit a regression line, the line of best fit. But the point is that the relationship between income and consumption is never a linear form of relationship. It will never be linear. It will be non-linear. There will be scatterness. In other words, it will be like this. So here we are measuring consumption, and here we are measuring income. Here we are measuring income. So our points are like this. Let us suppose this is one point. So when income is this, consumption is this. When income is this, consumption is this. Similarly, when income is this, consumption is suppose this. When income is this, consumption is, let us suppose this. When income is this, consumption is, let us suppose this. When income is this, consumption is, let us suppose this. So these are the points A, B, C, D and E. We have 5 combinations of income and consumption. We have 5 combinations of income and consumption: A, B, C, D and E. Now, our next task will be how to find out the line of best fit from this data. From this data on income and consumption. How to find out the line of best fit. The line of best fit may be like this, it 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 may be like this. Various shapes we can find. Now, which line is to be taken as the line of best fit? Which line is to be taken as the line of best fit? And that will be dealt with by this OLS method. That will be dealt with by the OLS method. Optimum least square. Least square. What is the meaning of least square? Least means the minimum. Square means square. Square of 2 is 4, square of 3 is 9, like that. So optimum least square means least square should be optimum. In other words, the squares, sum of the squares of that is another point. OLS method derives, or OLS method chooses that line to be the line of best fit, which minimizes the sum of the squares of the deviations. It minimizes, very important, it minimizes the sum of the squares of the deviations. What are deviations? That question now arises. What are deviations? Very simple. Nothing to be bothered about. So, let us suppose these are the datas. Now, we assume that this is the line of best fit, which is x is equal to a cap plus b cap of y. X is equal to a cap plus b cap of y. Why we have denoted cap? Why we have denoted caps to the values? Because we have assumed that, represented, we have already derived the coefficients, the values of the coefficients a and b. That is a cap and b cap. So here a cap is 780 in the earlier case, in the numerical example, and b cap is 0.8. Now, what are deviations? This is one deviation. This is another deviation. This is another deviation. And similarly, this is another deviation. So these are the deviations from the line of base split. Deviations of the various combinations, income consumption combinations from the line of base split. Let us suppose this deviation this is positive deviation, these are negative. There are two positive deviations, two negative deviations. Let us say this deviation is, first deviation is plus 2. This deviation is minus 3. This deviation is plus 1. And this deviation is minus 2. These are the deviations. Now what are the squares of the deviations? 2 2s are 4. 3 3s are 9. 1 1 are 1. And 2 2s are 4. These are the squares of the deviations. These are the squares of the deviations. And if we add up these things, what is the result? It is 18. So what is 18? 18 is sum of the squares of the deviations. So we try to make this sum of the squares of the deviations optimum, minimum or least. That is the main theme of the method of optimum least square. So if we take another line, let us suppose this is another line, this is another line. So someone may question why we have selected this line and not this one. The answer is that from that line also there will be some sum of squares of deviation. And for that line the sum of squares of the deviation should be greater than 18. It will be greater than 18. Maybe, might be 20, might be 25, etc. etc. So under the given circumstances, we have sum of the squared deviations have been minimized by the line x is equal to a cap plus b cap y. And this is the line of best fit. So in other words, the particular income consumption behavior is most appropriately represented by this x is equal to a cap plus b cap y line. So that is OLS. That is the OLS method. Now the point is how to find out the OLS equations. To apply the OLS method, we have to derive the OLS equations. And here the concept of mathematics, the concept of differentiation and minimization enter the picture. We have to minimize the sum of the square deviations. Therefore, the concept of minimization, mathematical minimization enters the picture. Now, you see, x, for x also we can give cap values because the various x values will be determined from a cap and b cap values given different values of y. So x can also be given as a cap value. Therefore, our next task will be how to derive the OLS equations, and we have to apply mathematics. So in the next class, we have to show this, how to apply differentiation, minimization process to find out the equations of OLS. Thank you for today. Thank you. This is for today.